So we're letting these random variables use up to 60 be i.i.d. uniform, and x is just a sum of these. We're asked now to find the MGF of x. So let's just start by defining the definition of MGF, and then see where that leads us. So the MGF of x is a function of t. That's just by definition an exponential, the expectation over e to the x. Now we're going to use Lotus. Basically, the definition of the integral, the definition of the expectation, which is the integral from 0 to 1, because it's uniform. So we are summing over, integrating over the support. And by Lotus, we can then take e to the x, and then we then multiply by the PDF of the uniform, which is 1 to the 1 minus 0 by definition. And then we take dx here. Now this is obviously just 1, so that simplifies a little bit. Now we're going to take x and then write out these random variables, which is just the following, using now the properties of well, several things we're going to do here. Use the properties of the exponential, and then use the fact that they're i.i.d, allowing us to multiply out each of those terms. So i.i.d here, and then we can do 1 over e to the 1 multiplied by to the 2. Continue along this path, 0 to 1, e to u60. Okay, and we ask what is the we can evaluate one of these terms, and then we're basically done when we then take the multiply by the factor of those 60 terms. So what is now, let's focus on this guy. What is this term? So this term is it's an exponential, and we arrive at it at the usual terms as we do when we evaluate these exponentials. So this is e t u1, and that goes 0 to 1 and divided by t, right? That is 1t limit where u1 is going, approaching 1, ut1 minus limit u was going towards 0, t, like that. And that is, so this term here is just et. This term here is just 1. So we end up then with 1t et minus 1. Okay, So continuing ahead here, we then see that we have 60 of these terms multiplied. And so get the following. And that is the MGF of X.